Hello everybody! In this video we're going to talk a little bit more about numerical precision in MATLAB. In particular, we're going to be talking about the built-in function EPS. You can think of this as standing for epsilon, and we'll see why in just a moment. So epsilon from your real analysis courses typically is a pretty small positive number. But just as like a quick recap, so let's say I have pi to the 4 times pi to the negative 4. And remember, we expect this to be equal to 1. Mathematically, it's equal to 1. But if I do something like, is this equal to 1 in MATLAB, it returns false. And in the previous video, we talked about how this is due to rounding errors and numerical precision. And we talked about how when you're working with real numbers, so in particular transcendental numbers like pi, or irrational numbers like root 2, for instance, we can definitely expect this type of behavior. But let me show you another example with just integers. So let's say I do 2 to the 60 plus 3, and I say, is this equal to 2 to the power of 60? So in a mathematical context, no, right? The left-hand side is 3 greater than the right-hand side. But if I evaluate this in MATLAB, it's saying true. So the main tool that we have to look at this behavior more precisely is with the built-in function EPS, like we said. So I type EPS, and if I do parentheses of 1, what this returns, so it's this very, very small number. It's about 2.2 by 10 to the negative 16. And basically, what's this saying? What this is saying is, what's the kind of the next number MATLAB knows about that's larger than 1. So for instance, let's say I have a number that lives in between 1 and 1 plus this value. If we can imagine this is epsilon, we're saying, if there's a number between 1 and 1 plus epsilon, what MATLAB does is it either gets rounded down to 1 or rounded up to 1 plus this value. So here we can see this is a very tiny value. If I do something like EPS of 2 to the 60, for instance, what this is saying is 256. So if you give me a number between 2 to the 60 and 2 to the 60 plus 256, it's either going to get rounded down to 2 to the 60 or rounded up to 2 to the 60 plus 256. So let's see a couple examples of this. I could say, is 2 to the 60 plus 3 equal to 2 to the 60? So again, this is the same example as from before. And we're seeing here, yep, MATLAB's saying that's true. What if we tried with 100? We could say, is 2 to the 60 plus 100 equal to 2 to the 60? That's also true. So keep in mind, these are all, we're adding values less than 256, which was what was returned by EPS of 2 to the 60. I could say 2 to the 60 plus 200, is this equal to 2 to the 60? And here we're saying false. So this is meaning that it's going to get rounded up. So we're going to say 2 to the 60 plus 256, oops, not 256, 200. Is this equal to 2 to the 60 plus 256? And MATLAB is saying here, yep, that's true. So again, this is kind of how we're able to determine kind of what is MATLAB going to return when we're dealing with very, very large or very, very small numbers, and when we need a lot of precision. So another thing that I want to show you is what happens if I do something like 10 to the power of 350. And you can see here, MATLAB has said, well, this is infinity. So from a mathematical perspective, of course, we know this isn't infinity. And in the grand scheme of things, this is quite a small number. But nonetheless, what's happened here is that this is a number that's just too big for MATLAB to represent using kind of floating point numbers. So we've kind of overflowed what we can represent in the computer. Another thing I want to emphasize too is, so notice when we called EPS of 2 to the 60, we got 256. So meaning anything between 2 to the 60 and 2 to the 60 plus 256 kind of gets rounded up or down. So anything in between kind of, it's like in this weird limbo state. So whereas for a really small number like 1, the EPS was way, way smaller. So the takeaway from this is there's a lot more precision for small numbers, and this makes sense, right? Like we want to be able to distinguish between 0.5, 0.75. versus large numbers where we have a lot less precision. And again, you can think about this even from in your calculus classes, right? When you're taking the limit of a function, so like if it's like x squared minus 1, for instance, as you're going to infinity, that minus 1 doesn't really matter at all. All that really matters is that x squared term that's pulling everything to positive infinity. If you're wondering what's the biggest number that MATLAB can work with on your computer, you can type real max. And here's what MATLAB returns. Yours might be a little bit different than mine, that's fine. But in case you're wondering, here's how you could find it. And I guess one other takeaway I want to highlight is it's not super important for this class kind of to know the ins and outs of numerical precision. We're not going to do very much with it. But what is important to know is that the computer is limited in how much accuracy it has, right? It's a finite resource. So it's just something that's important to know about. And also, for those of you who have made it to the end of the video, here is a very popular quiz question that can be asked. So maybe on a quiz, I ask you, let's say I have some number x, I don't know. Let's define x to be like 2 to the 60 again. And if on a quiz I say, is it always true that x plus 0.1 is equal to x? So on a quiz, maybe I ask true or false. This statement always returns false. Well, here is one example where it returns true, right? Because the numerical precision for when we're dealing with 2 to the 60, remember the EPS of this was 256. So x plus 0.01, that's just going to get rounded down to 2 to the 60. So here in MATLAB, these are the same. So again, moral of all of this is this double equals operation is very dangerous in general. So not just for numerical precision, we'll see kind of later in the Python aspect of the Python portion of the course, why double equals isn't always the best choice. For us, remember, the safer way to do things is to look at the distances between objects or numbers and say, is the distance between them small? So I can say, so we have x, let's say y is equal to x plus 0.1. And now I can say, well, is the absolute value of x minus y, is this less than, let's say, I don't know, 0.9, for instance. And we can see here that it's true. This 0.9 was completely arbitrary. You have to determine the tolerance that you're comfortable with. I guess here the distance is exactly 0.1. So let's say if I do less than or equal to 0.1, it's going to return true. Otherwise, I think this is a good place to stop the video. Thank you for watching, everyone, and I will see you in the next one.